Okay, for number one, we are going to multiply. We're going to times the 2 and the 4, and we're going to add the exponents, okay? Because it's multiplication and they have the same bases. Bases are x, okay? So the coefficients, we're going to go ahead and just multiply. 4 times 2, it's 8. All right, same base, xx, so we're going to add those exponents, keep the base of x. 3 plus 3 is 6, so it's 8x to the 6th. All right, number 2, which one of the following expressions is equivalent to 4 to the negative 3? All right, negative exponent, I'm going to rewrite that as a fraction. 4 to the negative 3 goes to the bottom, goes 4 to the positive 3. 1 goes in the numerator, okay? And, oh, look, it's already right there, option C, 1 over 4 to the positive 3. Number 2, which expression is not equivalent? All right, so let's go ahead and take this step by step. We're going to do 6 minus 3 because it's going to be subtraction. Bases are the same. Bases are both 6. 6 minus 3, oh, I'm sorry. Do that again. 3 minus 6. 3 minus 6 is a negative 3. Okay, 3 minus 6 is negative 3. So that's going to be our new exponent. So it's going to be 6 to the negative 3 power, right? 6 stays the same. 3 minus 6 is negative 3. All right, so 6 to the negative 3. Hey, look, these are equivalent. Okay? All right, so it wants not. So that one is equivalent. Let's cross that one out. All right, so let's go ahead. It's a negative exponent. I'm going to rewrite that as a fraction. 6 to the negative 3 goes to the bottom. 6 to the positive 3. 1 goes in the numerator. All right, so 1 over 6 to the third, that is also equivalent. Let's cross that one out. All right, and then 6 times 6 times 6, that's 216. So I have 1 over 216. So that's also equivalent. So the one you know has to be 1 over 6 squared. Once you knew it was 1 over 6 to the third, you knew that it couldn't be 1 over 6 squared. Okay. All right, number 4. All right, 8 to the negative 2, so I'm going to rewrite that as an exponent. Rewrite that as a fraction because that is a negative exponent. Rewrite it as a fraction. 8 to the negative 2 goes to the bottom. 8 to the positive 2, 1 goes in the numerator. All right, this is 8 times 8. 8 times 8 is 64. That's 1 over 64. Okay. All right, so now it says find the missing exponent. 5 to the 11th divided by 5 to the something equals 5 to the 4th. 11 minus what equals 4? Okay, because we know we're going to have to subtract because this is a division, right? Same base of 5. 5 minus what equals 4? Well, I'm sorry, 11. Keep making mistakes here. 11 minus what equals 4, right? 11 minus something equals 4. You have the base of 5. 11 minus 7. So it has to be 11 minus 7 equals 4. Okay, so that's the exponent right here. So that has to be a 7. Okay. All right, number 6. Larry has written 6/10 of his book. Which decimal represents the part of the book report he has written? So 6/10. All right, so you know you have your decimal. The first place right after the decimal is the tenths place. Okay, so that's 0.6. Okay, so and of course we have 0 here. It's less than 1, so 0.6. Okay. All right, next one. Let's take a look at number 7. All right, so number 7, we have a power taken to another power. This is where we multiply. This is negative 2 times 7, which is 14. Okay, so I have 8, negative 14. So I have 8 to the negative 14. Okay, I'm going to rewrite that as a fraction. Okay, so I'm going to put a 1 in the numerator. 8 to the positive 14 goes in the denominator. Okay, there it is right there. Number 8, which of the following is true? All right, so for A, right, if I'm multiplying, I add the exponents. 7 plus 3 is 10. This is x to the 10th, not that. So that's not true. Power taken to another power, just like in number 7, I would have to multiply, right? 4 times 7 is 28. This would be x to the 28, okay, not x to the 11th. This one, division, so I have to subtract 7 minus 4 is 3. Hey, x to the third, this is the one, okay? This one, x to the negative 4, remember this, you'd have to rewrite as a fraction, 1 over x to the fourth, not just x to the fourth. So the only one that's true is option C. All right, number 9, 6 to the 0 times 4 to the negative 2. All right, remember anything times 0 is 1. This is 1 times 4 to the negative 2. Well, anything times 1 is going to be itself. So this is going to be 1 times 4 to the negative 2. This is just 4 to the negative 2. Okay? All right, negative exponent, I have to rewrite that as a fraction. Numerator at the top is 1. 1 over 4 to the positive 2. And 4 squared is 4 times 4, which is 16. So this is 1 over 16. Okay, so that's option D. All right, number 10. Let's go ahead and simplify this. First, I have a division here. So division, same base of v. I'm going to subtract 3 minus 8. 3 minus 8 is negative 5. So I have v to the negative 5 times v squared. All right, so now I have a multiplication, so same base again. I'm going to go ahead and add. Okay, so for addition, negative 5 plus 2 is negative 3. So I have a v to the negative 3 power. All right, negative exponent. I have to rewrite that as a fraction. 1 over v to the positive 3. Okay. All right, number 11. There's a 2 outside the parentheses, so everything inside the parentheses gets a 2 with it. That 4 gets a 2 with it, 2 exponent. That x gets a 2 exponent with it. Okay, and the y gets a 7 times 2. 7 times 2 is 14. All right, so let's simplify this 4 squared. 4 squared, 4 times 4 is 16. X squared, y to the 14th. Okay, so that's option C. All right, number 12, same base of 6. You're dividing, so you're going to subtract 5 minus 7 equals negative 2. So this is 6 to the negative 2. Rewrite that as a fraction. 1 goes in the numerator, 6 to the positive 2 goes in the denominator, and 6 to the positive 2, that's 6 times 6, that's 1 over 36. Okay, next one. Number 13. All right, so we have some coefficients here. This is a multiplication problem, okay? So the coefficients of 4 and 6, we're going to times those. Okay, we're going to times the 4 and the 6 together. All right, so 4 times 6, that's 24. There is no other v, so I'm going to just bring over the v to the third. And then the c here has an exponent of 1. So I want to add those exponents. C to the 7 times c squared, 7 plus 1. C to the 7 times c to the 1. 7 plus 1 is 8, so this is c to the 8. So it should be 24v3c8. C8v3, the order doesn't matter there. It's just D. Okay. All right, number 14. That 2 outside, that exponent of 2 goes to everything inside the parentheses. So the 4 gets a 2, so you get 4 squared. That 5 gets a squared, so 5 squared. That x gets a squared, x squared. Okay, 4 squared is 4 times 4, that's 16. 5 squared is 5 times 5, that's 25. And then the x squared stays, so I got 16 over 25 x squared. All right, number 15, it's division. I have the same coefficient, so I'm going to subtract the exponents. 20 minus 10 equals 10. Okay, so the base stays the same, 7 to the 10th power, and I see that as option D right there. All right, number 16, 9x to the negative 4, y to the third. I see a negative exponent right here, this x to the negative 4, so that's, I'm going to rewrite it as a fraction. The 9 and the y3, they stay. X to the negative 4 is going to become x to the positive 4 in the denominator. Okay, so it looks like it's option A. Number 17, solve the equation. X squared equals 36, so I know that x times x equals 36. Okay, so something but multiplied by itself. I know 6 times 6 equals 36. right? And I also know negative 6 times a negative 6 equals 36. Okay, so you have two answers here, negative 6 and 6. Number 18, which of the following numbers is not a rational number? So, which one of these is irrational? So since it's not a rational number, it has to be an irrational number. Okay, remember there's three visual indicators for irrational numbers, three dots, pi, and then square root of an imperfect square. Okay, I don't see three dots or pi anywhere, but I do see the square root of an imperfect square, square root of 11. All right, number 19, what's the best estimate for square root of 25 plus square root of 15? I know the square root of 25 is 5. Okay. Square root of 15. Square root of 15 is between the square root of 9 and the square root of 16. So it's between 3 and 4. So it's 3 point something. It's really close to that bigger integer. Okay, so it should be bigger than 3.5. This is going to be, we'll say 3.9 since it's really close. So this is 3.9. 5 plus 3.9. Well, 5 plus 3 is 8. Then you got another 0.9, so 8.9. All right, which of the following sets contains only rational numbers? Okay, so they can only have rational numbers. So it cannot have, okay, it cannot have the three dots. It cannot have pi. It cannot have the square root of an imperfect square. Okay? All right. A, I see the three dots. B, I see pi. C is it, because D has square root of 3, which is an imperfect square. Okay? So C doesn't have any of those. Number 21, h squared to the 5th power. So this is where I am multiplying, okay? Power taken to another power. 2 times 5 is 10, so we have h to the 10. All right, number 22, x to the 3rd equals 8. So you know it's x times x times x equals 8. So let's try 2. 2 times 2 times 2. 2 times 2 is 4. 4 times 2, that equals 8. X has to equal 2. All right, number 23, which point on the number line best represents square root of 83? All right, so let's go ahead and take a look at square root of 83. It is between the square root of 81 and the square root of 100. So it's between 9 and 10. It's between 9 and 10. It cannot be m. M is less than 9. Okay? All right, so we know it's 9 point something. It's really close to the smaller square root of 81. It's really close to the smaller number. So it has to be less than 9.5. Okay? And it's pretty close to that square root of 81. So I would say, 9.1, okay, or 9.2. All right, looks like n, right, is the only option here that's less than 9.5. Okay, so you want option n, point n. All right, number 24, which list shows the numbers in order from least to greatest? Okay, so first let's get decimals for each of these. Square root of 38. So square root of 38 is between square root of 36 and square root of 49. So it's between 6 and 7. It's 6 point something. It's kind of close to that lower 6. You can say 6.1 or 6.2. Okay, so we'll say this is 6.2. 63% we know is 0.63. And negative 19 over 3. So let's do some long division here. 3 into 19. Now let's put a 0.0. Okay, right at the decimal point. 3 goes into 19 6 times, because 6 times 3 is 18. If I subtract, 19 minus 18 is 1. I bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. I subtract and bring down I subtract, I get 1, bring down another 0. 3 goes into 10 3 times. Okay, 6.3. Looks like I'm going to keep repeating. Okay, so 6.33. So it's going to be a negative 6.33. Okay, least to greatest. So the smallest number here is negative 6.35. It is the bigger negative, right? Then comes the other negative, negative 6.33, which is negative 19 over 3. Then you got the positives, 0.63 and 6.2. So option C is in order from least to greatest. Okay, number 25, estimate the square root of 48 to the nearest tenth. All right, square root of 48 is between square root of 36 and square root of 49. It's between 6 and 7, so we know it's 6 point something. We know it's not D, we know it's not B. It's really close to that next biggest number, okay? So it's got to be bigger than 6.5, right? 6.9 is a pretty good estimate. All right, last one. Evaluate 2 to the 4th times 2 to the 6th divided by 2 to the 7th. Well, the top we can multiply here. Everything has the same base 2, right? So we can go ahead and add these exponents. 4 plus 6 is 10, so I have 2 to the 10th. Then here I have 2 to the 7th. Now I want to subtract because I have a division, okay? 10 minus 7 is 3, so this is 2 to the 3. 2 to the 3rd power, that's 2 times 2 times 2, and that's 8. Okay?